Good morning, guys. So today we're going to start looking at something called a vector. Okay, so to just give you the definition to start with, a vector is a quantity that has both magnitude and direction, compared to what's called a scalar, which is a number that has only magnitude. So, for example, an example of a vector would be something like velocity. Okay, velocity would be, say, if I look at my speedometer and I see that I'm traveling 50 miles per hour, and then I look at my compass and I see that I'm going in the direction of northwest. So this has both magnitude as well as direction, so that is a vector. Compared to speed, which is just saying I look down at my speedometer and see that I'm traveling at 50 miles per hour. That has only magnitude, so that is a scalar. Okay. Now, there's a few different ways that we can represent vectors, the first of which is to draw them out geometrically. So when we draw out a vector geometrically, we just use a line segment with an arrow at the end. So I could say, for example, just draw out a little arrow right here, and I could call that my vector V. Okay, so the length of your line represents the magnitude, and the arrowhead is giving you the direction. So the longer the vector, the bigger the magnitude. The shorter the vector, the smaller the magnitude. Okay. All right, now also notice when I labeled my vector here, I put this little arrow over top of my V. Okay, that is a notation that just means that something is a vector. A lot of times, typically the notation is in handwriting, you'll use the little arrow to represent a vector, and then in print, you'll use like a bold italic font. So if you're reading through the textbook or anything, a lot of times they won't use that arrow over top of it just for convenience sake of typing. Instead, they'll use that bold italic font, and that means that you're looking at a vector. Okay, now the first thing that we're going to look at with these is how to do operations with our vectors, so how we can, say, add or subtract vectors together. And the way that we're going to do that is using something called the tip-to-tail method. So to show you how to add these, I need a second vector here. I'll just sketch out a second vector. There we go. I'll call that guy vector W. All right, so let's say I want to add my two vectors together. Okay, I want to get V plus W. Okay, so the way that we would do that is we would take our vector V. Now, when I talk about this tip to tail method of adding and subtracting vectors, what I mean by the tip and the tail, so the point of the vector is the tip, the other end of the vector is the tail. Okay, so this is the tip, this is the tail. So in order to add vectors together, we basically connect them tip to tail. So if I'm looking for V plus W, I'm going to start with my vector V, and then right at the tip of V, I'm going to attach my vector W. I'm going to attach W right to the tip of V. Okay. All right, now the resultant vector, or our answer, if you will, is going to be the vector that starts at the tail of the first vector and ends at the tip of the second vector. So this would be our resultant vector, V plus W. Okay, so this is the idea of the tip to tail method of adding vectors together. There are other methods that you can use. There's another one where you can sort of draw out a parallelogram. I personally like the tip to tail method a little bit better. I think it's just a little bit easier to see. Okay, so this is the method that we're going to be using in this video. Okay, Now, one other thing with these, okay, as I mentioned, vectors have two things. They have both magnitude as well as direction. So the magnitude of a vector, when we're looking at geometric vectors, is just represented by the length of the vector. So let's just take this vector v again. All right. So the magnitude of this vector is the length of it. Well, if we want to figure out the length of this vector, the easiest way to do that is just to draw out a little right triangle. So we're going to have a horizontal component and a vertical component to this vector. And if we want to find the magnitude, or we want to find the length of this vector, then we're basically just finding the hypotenuse of a right triangle, so that's just Pythagorean's theorem. So the magnitude of our vector would be, from Pythagorean's theorem, square root of a squared plus b squared. Okay. All right, now the direction of our vector, we know that this arrow on the end is telling us the direction that our vector is going, so we can find what's called a direction angle, which I'm going to call theta right here, and we measure theta just like we normally would. If you think about your unit circle, angles are measured counterclockwise from the positive x-axis. Okay, so basically think about starting your vector at the origin and then measuring your angle from the positive x-axis. So this would be our theta right here. All right, so if we're trying to find theta, we can just think about our SOHCAHTOA. If we know A and B, we can use our tangent function, and we just have tangent of theta is equal to B over A. Okay. All right, so let's go ahead and let's take a look at a couple examples of finding both the magnitude and direction angle of some vectors. Okay. All right, so I've gone ahead and drawn out four vectors here. So we have four vectors, u, v, w, and z. So if we want to find the magnitude and the direction angle of our vectors, we're basically just going to think about sketching out little right triangles for our vectors. Okay, so let's go ahead and let's start with vector u, right? So with my vector u right here, if we want to find the magnitude and the direction angle, we're just going to start by drawing out our little right triangle. Okay, so for our components, we are going 1, 2, 3, 4 units to the right, and we are going 1, 2 units down. So since it's down, our vertical component is a -2. Okay. All right, so the magnitude of the vector is just the length of the hypotenuse. So we're just looking at Pythagorean's theorem. Okay, so the magnitude of u is going to be equal to the square root of 4 squared plus -2 squared. Okay. All right, so that would be the square root of 20, or if we simplified that, 2 root 5. Okay, so that's the magnitude or the length of this vector. Okay. All right, so then our angle. Okay, so for our direction angle, just going to look at this little angle right here. Okay, so always measure angles from the x-axis, right? So if we want to find theta, we have the opposite and the adjacent. So we can say tangent of theta is equal to -2 over 4. All right, well, that's not something on our unit circle, so we're going to have to plug this into our calculator. So use an inverse tangent of -1/2. And then if we plug that into our calculator, let's go ahead and do degrees, we would get -26.57 degrees. Okay. You could also, if you prefer to think of it as a positive angle, you could look at this guy as the positive angle. Just add 360 to this, and then you would get 333.43 3 degrees. So either answer is fine. They're both leading you to the same place, but just know that you can write it as either the negative or the positive angle. Okay, let's go ahead and look at vector v next. Okay, so v is pointing straight down. Okay, so this one we're going 1, 2, 3, 4 units down. Okay, well, since this one isn't at an angle, it's just going straight down, we don't have a triangle to build, so we don't have to worry about Pythagorean's theorem. The length of our vector is the magnitude of our vector, and we just said that the length of this vector is 4. I should have said here, though, negative 4 units down. Okay, now magnitude, though, since it's a length, is always positive, so our magnitude is 4. Okay. Now, as far as the direction angle goes, if we just think about measuring from the positive x-axis, this is an angle of 270 degrees. Okay. All right, so parts C and D are similar. I'm going to leave those for you guys to try on your own.